for the last almost a year, we've been online. So here we are with another online session. That doesn't mean we're living in computers, of course. That'll be for the future. But today, it's our pleasure to have a speaker, Rishabh Banga from Intel, and a bit about his bio and his talk. His bio is he has a rich experience in working in both a multinational corporation as well as startups and non-governmental organizations in the areas of product management and development of products ranging from IoT to AI and automation. He has mentored teams from Australia and India for Ericsson Innovation Awards, both of which went on to finals. Outside of work, he's also part of the Intel Software Innovator Program and Intel's IoT Advisory Board. He was awarded first prize by the Prime Minister of Netherlands in a hackathon, jointly organized by UNFPA and Netherlands Embassy. And finally, if you're a student working or working professional hoping to get associated with Hackers Tribe Foundation, then please fill out, he's got a contact form that's linked from the meetup.com site. So yeah, with that, and I guess a little bit about the talk. It's, about AI at Intel, Neural Compute Stick, AI Dev Kit, and more. So with that, please, Rishabh, the floor is yours.
Thanks, Trent, for the amazing introduction. Good evening, everyone. So as Trent has already said, this session will be basically about how Intel helps you with streamlining your entire development process on the edge, right? So I'll begin with that. Obviously, Trent already gave a really good introduction.
Excuse me. There's a horrible echo. Abhishek, can you do anything about it? I turned off. Okay, maybe it's just on my side. So yeah, I'm sorry. Let's just go on.
All right. So should I restart? Yeah. Thanks, Trent, and thank you for the really good introduction. As Trent has already said, so basically we are on the edge, right? With that, since Trent already gave a really good introduction, I'll only add on to it by saying that I'm currently an executive director at Hackers Tribe Foundation, which is based out of India, working towards tier 2, tier 3, and tier 4 education institutions. As part of the Intel Software Innovator Program, I am delivering this session right now. Right. So the first question is, and what is the edge? I mean, people have been talking about AI, IoT. So till now, when I was at the 2-3 years back, what used to happen was we had these huge machines, right, which smaller, but by the end of it, you still were dependent on either a really high specs processor or something similar for all your training and related needs, right? But that does not usually happen in real life scenarios. In real life scenarios, once you're trained with the model, you also need to run it. And even with that, you need some, to some extent, really good processing power. So this is where the entire concept of, at the edge came in. It is not, right? You're not standing at the edge of a cliff or something like that, or not, I would say the Microsoft browser edge, right? It is basically your real-time evaluation of a already trained model, constraints of power, latency, and memory, right? So in this case, you cannot use any and all models. These are specifically designed or trained models that are tuned to the above mentioned constraints, right? So there are models like Squeaky are tuned for similar inferencing on PCs and embedded devices. Facts and figures regarding on the edge things. So devices, as we all know, are creating an overwhelming amount of data. Computer vision and deep learning is challenging, has its own challenges to run at the edge because of the compute intensive resources. So figures 43% of the share of the AI tasks, right, will be happening on the edge, on edge devices versus the cloud by 2023. 15 times will be the growth in devices with the edge capabilities by again 2023, right? So with respects to how Intel comes into the picture, these are the offerings that we usually get, right? Depending on the kind of deployment you need, depending on the use case you have. For example, whether it's healthcare, whether it's autonomous vehicles, industrial, tail, and any and all use cases. So Intel offers frameworks, kernels, hardware, and finally platforms, right? I'll talk about mostly the platforms, which is the Intel OpenVINO, the Intel DevCloud for the edge, and another hardware, which is called the Intel Neural Compute SIC. About another edge device, which is, as people would already know about, single base compute resources like Raspberry Pi and everything. Intel has its own with Up Squared AI Vision Dev Kit. That is another topic that I'll be talking about in this session. So if you think about it, and I mentioned earlier that the development journey will be simplified using Intel, right? So this is how it actually happens. Model. Now this is an important part. You're supposed to have a pre-trained model, or you could probably utilize any of the existing models that Intel offers, right, as part of the SDK. So the first step is obviously you train your model, right, wherever desired, and then you optimize it using either the pre-trained models as I mentioned, or whatever you've trained right now with the Intel distribution of OpenVINO toolkit. Now we'll get into what OpenVINO toolkit is later on, as well as the neural compute SIG. But for now, this is the reference for you. The third step is deploy, where once you've optimized it for edge devices, you deploy it on any and all hosts that you're thinking about, whether it's a Raspberry Pi 3 or Up Squared kit, or even if your laptop, I mean, if you want to test it out, right? And finally, productivize. So this is where Intel has its own range of devices, Radius X VPU, right? And but this is the most important part, right? So Intel offers a write once, deploy everywhere kind of thing. So this helps because once you've written it and optimize it, this can be all the Intel offerings and all the Intel architecture that is available. Toolkit. So OpenVINO toolkit was launched in 2018, right? And it provides the following features. It's complementary to most of the major frameworks. It has high performance and efficiency on the edge. It provides cross-platform flexibility and supports traditional libraries, including OpenCV, OpenCL, and OpenVX, right? Image provided, the major frameworks that are talked about, right? Cafe, TensorFlow, MXNet, and Kaldi, all of these are supported currently. Gradually, obviously, Intel will include other major frameworks as well. So how this entire thing works is that once you have the pre-trained model, right, inside the OpenVINO toolkit, two different components, the model optimizer, engine, right? Again, I'll talk about the following slide. This is the flow that happens. From the pre-trained model, it goes to the model optimizer where it optimizes it into a specific format that can be read by the inference engine. This section is where things get actually interesting because you have a lot of plugins that you can use. You have the CPU plugin, the GPU plugin, you have the VPU plugin. So I mean, depending on your own requirement on how you want it to be done, you can choose any of the plugins. And finally, product. So these are the components I mentioned earlier. So model optimizer is essentially a Python-based tool, right, which imports the trained models or pre-trained models in this case and converts them into a toolkit representation, right, which can be read by the inference engine. So this is important because it optimizes for performance and space, right? With, as we discussed earlier, with respect to edge devices, that is very crucial, right? So this provides a bigger boost from the conversion to data type matching hardware. Inference engine, this is a high level interface API. It is implemented dynamically, right, for each hardware type, as I mentioned earlier, CPU, GPU, VPU, and others, right? So obviously, because there are different plugins for each, this delivers the best performance for each type without requiring you as a developer to implement and maintain multiple code pathways. Apart from this, from the entire OpenVINO toolkit, there are a couple of other things that you get along with the toolkit. So there's a workforce profiler, which essentially allows you to visualize the performance data that you have, right? So this can be when you're doing analysis for CPUs, GPUs, and VPUs, sometimes even FPGAs as well, if you're into that, right? So why, again, this is important because it helps you to identify whatever bottlenecks there are, right? And finally able to tune it. Really a useful feature for developers because I mean, finding a bug and being able to solve it is like one of the important tasks of any developer, right? So the result is that using the deep learning workbench, you're easily able to profile you have and boost the model performance. The capabilities include visualizing performance data, directing access to models via the open model zoo, and tuning and optimizing models via the Vinograd algorithm. Apart from that, other one is deployment manager, which is again a Python-based tool. Deploy specific inference-based parts, right, with the data, such as pre-compliant application models and configurations. Diagram on the right side, it's simply you install OpenVINO, develop the application, create a deployment archive with your data and inference engine runtime, and finally execute the smaller deployment on any target device, right? The importance that basically allows users to execute smaller deployments on a targeted device. So the capabilities are that it generates deployment archives or tarball in this case using the collected data and inference engine runtime. If you think about it, right, how do actually all the edge device or the edge use case come into the picture? I'll talk about in this slide the key verticals that are impacted. So that's industrial, health and life sciences, retail, and safety and security. So in each of these, machine learning or deep learning comes into the picture, actually in some cases reducing whatever is there currently. For example, industrial, there's reduction of on-site maintenance time. In case of retail, you get better use cases with faster time to market, right? Personalized experience. This is also the same case in health and life sciences. For safety and security, you actually get, per dollar per watt. So this is how all these are the major verticals that have been impacted. Obviously, there are further more use cases once you start working on it. Case that are supported till now, right? And as you can see, I've mentioned it's supported by NCS2, right? The neural compute stick 2 is the current hardware that is being marketed across and is the successor to its predecessor neural compute stick 1, or as we call it, neural compute stick. So depending on the architecture you go for, there's Cafe, there's TensorFlow, and MXNet, right? And you can see there's a huge list that you can utilize it and that are actually supported, right? And this list keeps on updating time. So remember how I said that it simplifies the entire process. So this is how it looks like right now. Right, you train the model. Now this could be any of the existing models, be it customer, community, or the open model zoo models, right? And once you have the model with you is where you actually optimize it via OpenVINO. Recall, I said that which is basically OpenVINO has two components. There's a model optimizer and the inference engine. So now you know how it works internally, right? From the model optimizer or the existing pre-trained models, loaded, and the inference engine will do its part of optimizing it across different Intel architectures. So when you actually go to the deployment part is you get a huge amount of architecture to utilize, be it the Xeon processors, the Atom processors, or any of the edge devices that Intel offers, the Movidius that I'll talk about when I talk about upsquared board. So these are all of the things. Now, additionally, there's also the deep learning workbench that I mentioned, model analyzer, the benchmark app, tools, including the OpenCL libraries and OpenCV libraries I mentioned about. Apart from the usual, vision-based use cases, you can actually optimize using OpenVINO for non-vision use cases as well. Language recommender and other ones, and these are the new publicly models that are supported, right? You have mobile net reach. So again, these are also some of the use cases that I mentioned earlier that you can utilize as a developer. Right. So NCS2 is essentially a USB stick, right? And it helps accelerate the deep neural network development. So what happens is once you're done with the model, once you've optimized it, is when you can actually bring in NCS into the picture. So it's you plug it to your laptop, you plug it to your edge device, and once you run the model, actually, via the flags mention that, I want to use the Movidius part, which is essentially you're saying NCS2, right? And that will basically help you in inferring your model. Freely across all the SBCs like RPI 3 three ARM64 and ARM7 host devices. You have versatility across Cafe, MXNet, Onyx, and TensorFlow, right? Deploy everywhere on all Intel architecture and other embedded devices, including the VPU and the Intel FPGA. So this is how the workflow looks like, and what I actually mentioned earlier. Basically, once you're done with the training of the model, is where you come to the profiling, tuning, and compiling part. So either you use it with a development host, right, and check it out, how the inferences, what performance it's giving, and whether you want to tune it further or not. The prototyping part, right, and where you can use an edge device or again a prototyping host, whatever is your preference or the use case in this matter. So these are the features, right? Supported frameworks include Cafe, MXNet, PyTorch, and TensorFlow. So essentially, you get exceptional performance per watt per dollar. It's a plug and play and prototype with low-cost edge devices, and operates with cloud computing dependence, right? Compute dependence. So we have done with the OpenVINO toolkit. We're done with the neural compute stick, and now upsquared AI Vision Dev Kit. So this is again one of the IoT plus AI devices that Intel had. We had the Galileo Gen 2, Edison, and this is the latest offering. Basically is a single board computer that prototyping, enabling developers to quickly implement computer vision solutions. Essentially three parts, unless you can add on a couple of more things: a USB HD camera, an AI core, which is the Movidius X core, and the upsquared board. This is how it looks like. So obviously you can easily purchase an upsquared board and use your own HD camera, right? AI core is the Intel Movidius that I mentioned earlier, and it has its own processing inside of it, right? So with this entire setup, either run your models on the cloud or utilize the toolkit and the System Studio for your own development. So these are some of the features. You have pre-installed custom OS and IDs, including System Studio and OpenVINO. You can detect, classify, and recognize objects with the upsquared board. There's ready access to 400 sensor drivers, right? You have optional Wi-Fi and cellular add-ons. Now the Intel Dev Cloud. So till now we've talked about all, I would say, apart from the OpenVINO toolkit, we've talked about mostly hardware-based things. You had the upsquared board, you had the Movidius stick. Now imagine instead of all of this, right? Do all of things apart from training a model on the cloud, right? So this is where DevCloud comes into the picture, and I hope all of you have registered via the link. I'll be sharing it again in a short while. The slide. So with that, what will happen is once you register, you'll get a link where you can actually access DevCloud for 30 days. And if you probably need an extension, then you can get an extension with proper reasoning, right? So Intel DevCloud actually has three different offerings. I'll be talking about the edge offering in this case. So you have the data center workload, the edge workload, acceleration. So again, when I talk about edge workloads, it's using computer vision applications with DevCloud, and which includes again a pre-installed and pre-configured OpenVINO toolkit. However, if you talk about the data center workload at the FPGA, those are again dependent on the kind of use case you're looking for. For example, in data center, you have C++ or DPC C++, basically data parallel C++, right? And you can program one API cross-architecture applications. In the case of FPGA, you can develop programmable solutions and with your own development needs. So this is the link that I mentioned earlier. It's iotevents.intel.com/register/Berlin machine. So once you go to this link, you can fill in your details. It mentions company ID, but ideally you should be able to do it with that. And then you'll get all the necessary details from which you can start for your own personal needs. So Intel DevCloud for Edge. This is where it gets interesting. So essentially you have Jupyter notebooks, both Python and C++. You have all the majorly supported frameworks. installs using again OpenCV, OpenVX, and OpenCL because it has OpenVINO pre-installed. So that's how you're able to do the entire things. It gives you 50 GB of file storage, and as mentioned earlier, it gives you 30 days of access. Works. So as I said, once you're done with the training, you can actually via start the entire using again OpenVINO toolkit. You can start the job queue, and here is where you can actually define existing hardware, be it your Xeon processors, be it your CPU, all of them all together, right? This is where once you align with the job queue, you run the entire thing, and once the inference is done for either the video or the audio, it results back. So to actually register is when you actually find there are a lot of different already existing Jupyter notebooks that you can use to get your hands dirty. And finally, once you're comfortable with it, begin your own implementation. So that was the end of the presentation. Any questions?
Okay. Yeah. Thank you very much. Oops. Thank you very much, Raj, for your presentation. Yeah, the first part about neurocomputers stick was at least to me very interesting. A lot of frameworks can be used. It's very open in that sense. You haven't talked much about
Yeah.
benchmarks. So let's take one example. Faster RCNN. That's what I saw on one of your slides. Is supported. How fast is it? Can I really deploy it using the NCS? I mean, how many? Let's say, how many frames per second do I achieve using it?
So in actually ran a sample use CNN in this case. What I found was two things, right? So convenient toolkit, you'll actually see some of the charts that you can actually look at. My case, I was using DevCloud as well as Xeon, as well as the Intel CPU and GPU. Along, in this case, I'll refer to it as VPU. For me, with respect to the inference engine processing time, I would say Intel Xeon took the most, right? And when I talk about the inference engine frames per second, again, Intel Xeon peaked at 155 with Intel CPU and GPU being 127 and 11. So I'm actually looking at the data right now. If you want, I can share it along with you guys. Just give me a minute. Mm. So, I mean, depending on your use case and the model, as you mentioned, the the framework and the benchmarks would differ. In my case, what happened was in case of inferencing, right? It's a one-time thing. It did not happen again. Second best after Xeon, right? So I have a GPU 1060 TX, and surprisingly, that was third. I guess it depends on the model itself, right? So actually, it's taking a lot of time. What I'll do is I'll share the link across. There's a Medium article that I wrote about 3 years back when actually I was using for a prototype that I was working on. Almost loaded.
Maybe then, I mean, if it takes too much time, maybe can you roughly indicate how it compares, say, with the competition?
Sure.
NVIDIA
Can you
just
see it now? It should be able to. It's a nano. So
yes.
honestly, I haven't, got my hands on it. It's a nano, so I cannot. But if you can see the screen right now, these are the metrics that I got.
Okay.
In terms of inference engine processing time, Intel NCS obviously had the most, right?
Hmm.
Followed by the Intel Core GPU, the Intel Core CPU, and the Intel Xeon. In terms of the FPS, had the highest with 155.
Sorry, what model
Intel's
problem was this based on?
So this was a normal CNN model that I had for different clothing lines. Basically, it was trying to figure out what kind of the brand of the clothes were. So if I give you a brief about it, was that kind of in a retail environment, in a brick and mortar environment, if you want to improve the entire things, give customized, I would say, offers to people, then what would be the best way about it? So if you could, basically look at a person's face, figure out looking at a product or not, and then since you already had the layout, you would be able to guess, what kind of brand were they looking at. If it's the brand name is not obvious, then you could probably send an offer there. Yeah, this is the um, you're getting an instant offer on this particular brand. The intention, but the model was a very small thing that I was just trying to figure out, because that was the first time Intel, I would say OpenVINO came into the picture and DevCloud, and I wanted to find out what exactly is all about, how use as Adrian, you picked out that, how useful is it actually in the first place? I mean, fine, it's there, but can it actually be used in a real world scenario?
Hmm.
And if yes, then, how useful will it be in the long term?
Hmm.
Because for plug and play
Thank
and,
you.
I was, yeah.
Thanks. There's a question on the chat channel, and it's about OpenVINO. You can use it for free initially. The question is, after the DevCloud trial ended, can you still use it for free?
So OpenVINO is open source, right? That can be used indefinitely on your own computer. Once we talk about DevCloud is a totally different offering, right? It's a cloud-based offering. You get 30 days of access depending on your requirement, right? There's an option that you can get for extension, but you have to provide a proper reason. It's deploying its resources, so they would want used properly rather than you probably use it for a day or a week and then leave it for the remainder part of time.
Mhm. Okay, thank you very much. With that, I would give the mic back to you, Trent.
All right. Can you guys hear me? Yeah.
Yep.
Great. And
Yep.
all right. Yeah. So thank you very much, Rishabh, for the very informative talk and for the Q&A. And I guess we only have just one speaker tonight for this meetup, so it's gonna wrap up faster than usual. It's probably maybe even a record for us. It's pretty fast. So that's cool though. With that, yeah, thank you again, Rishabh, and thanks everyone for attending our meetup. And we'll see you next month. Bye.
All right. Bye bye.